Students of BSc Part 1 and respected listener, a very good evening and welcome all of you to today's lecture of chemical kinetics. The topic selected from chemical kinetics, the title I have mentioned on the blackboard: order of reaction, molecularity and pseudo order of reaction. The topic I have mentioned on the blackboard, I will deliver today the lecture on these topics, which is selected from BSc Part 1, Paper 3 Physical Chemistry, selected from Unit 5th, titled as Chemical Kinetics. All these students, I bring to draw your immediate notice and focus on these topics, which is beneficial to explain the fundamental structure, mechanism in any chemical reaction with the variation, with the changing of concentration either of the reactant with respect to that is of product and with respect to that is of timings. The various typical questions set in various competitive examinations like engineering, medical, as well as in BSc Part 1, Paper 3 Physical Chemistry, based on order of reaction, molecularity and pseudo order of reaction. First two topics, order of reaction and molecularity, in our previous video of chemical kinetics in depth of form we have explained. Today I will deliver about the pseudo order of reactions. First of all, in order to define the order of reactions here, order of pseudo order of reactions, how will you define pseudo, as it is evident with the nomenclature with the name of pseudo to create in suspension condition, to create the dual nature, to understand the dual concept, to understand about that is of a double meaning, of that is of fraud reactions. Why the pseudo terms is involved in chemical kinetics here? First of all, I want to clear the concept of chemical kinetics. In any chemical reaction which is undergoing, the fundamental basic rule in chemical kinetics, or the normally the general rules, normally the generally that is of rules and laws, any chemical reactions, order of reaction and molecularity to have the same value. In our previous video we have explained order of reaction is unity and unimolecular reactions. Second one, order of reaction is to have bimolecular reaction. Order of reaction to have 3 to possess trimolecular reactions. It is the fundamental rules in chemical kinetics. Normally, generally all the reactions undergoing to have the same order of reaction and molecularity. But there are also some pseudo reactions, dual reactions. Suspension order of reactions are known, in which order of reaction and molecularity are different. In order to define the pseudo order of reaction, are those reactions in compact form. I would like to define order of pseudo order of reaction are those reactions in which order of reaction and molecularity are the different. Why order of reaction and molecularity in chemical reactions have been observed in different value? It happens, it can be explained on the behalf of two important that is of factors. First one factors is related to that is of excess concentration of either of the one reactant which is present in chemical reaction in excess concentration, in dense concentration, in bulk concentration. First factor of the reactant the presence of first reactant in excess concentration, whose concentration doesn't change the velocity of the reactions. In such a position, order of reaction and molecularity to give the different value. Second one, factors which is responsible to give the different value to explain the order of reaction and molecularity, that is mechanism. On the behalf of mechanism, various reactions occur in various steps, more than one steps. Out of these steps, the reaction which is undergoing slow steps to determine the rate determining step. In rate determining step, how many numbers of molecules reactant are present, to count such molecules to give the order of reactions. In order to define pseudo order of reactions in our previous video, first factors we have explained, which is responsible hydrolysis of an ester in which ethyl acetate, when is treated with that is of H2O to produce acetic acid and ethyl alcohol, due to the excess concentration of H2O, its concentration doesn't change or affect the velocity of the reaction. The velocity of the reaction is dependent upon initial concentration of ethyl acetate. First example, in which due to the excess concentration, dense concentration of H2O doesn't influence the velocity of the reactions here. Second one, factor which can be explained on the behalf of mechanism here. Before proceeding of today's lecture based on pseudo mode of reaction, I give to you some important interesting example to explain the pseudo term which is related to our daily routine life. I want to clear about the pseudo term in your mind. First interested example which is related to daily routine life. My first questions to all of the students, the thing which is caught in my hand. My questions to all of the students, what is this? After the rotation, forward direction, backward direction, upward direction, downward direction, you have to guess, you have to respond. What is this thing? I think in your mind your answer will be it is the piece of sweet. Hence, but the exact answer, the exact response of this thing, that it is a bathing soap, to create the pseudo concept in our mind. Once again, my questions to all of the students, the thing which I am having here, what is this? Students respond, this thing piece of sweet, but it is your wrong answer, wrong response. The right answer, it is that is of bath soap. Next question, to explain the pseudo term. My next question to all of the students, what is this? I think after your analysis, your response will be, it is duster. But you know the exact answer, that is of its exact answer, it is that is of shoe shiner. Again, to create the pseudo concept in your mind. Is similarly, third one and last example, to explain about the term pseudo. What is this? In my hand, the thing I have in my hand, after the rotation, forward direction, backward direction, upward direction, downward direction, you to guess, you to respond. What is your answer about this thing? I think in your mind you will respond to me, you will answer to me, it is duster, but it is that is of the exact answer here, that is of glass cover. It is sunglass cover here. Again, to have the pseudo answer in your mind. So in the same condition actually as we think, but just reverse opposite results are observed here. Observed here is our per, that is of opinion here. As we think just doesn't happen. So I mean to say, as our reverse results are produced, our reverse results, opposite results are achieved as our per opinion, is our per judge here. So these were the fundamental example I listed you to explain the pseudo. Now let us turn the, one by one to explain the pseudo order of reaction here, in which order of reaction and molecularity are the different. First one, the decomposition of, first one important example, twice mole of N2O5 to produce 4NO2 plus, that is of O2. Example number 1, the decomposition of nitrogen pentaoxide of its 2 mole to give, that is of 4 mole of NO2 plus O2. To define the pseudo order of reaction, suppose I asked to you, students of BSc part 1, what is the order of reaction and molecularity? I think your answer will be, that is, since 2 mole of N25 is present here, so I think you will answer, you will respond to me that order of reaction, that is of 2, but it is your incorrect answer. Order of reaction, that is of 1, and molecularity, that is of 2. So it is the example in which order of reaction and molecularity are the different. It is the perfect example of pseudo order of reaction in various competitive examination, engineering, medical as well as physical. Such a specific example and the determination as order of reaction set in these competitive examination, you have to judge, you have to analyze, but overall these the decision exact answer dependent upon, that is a second factor based its mechanism here. First one, the mechanism for the identification for the determination of order of reaction in which twice mole of N25 to produce 4 mole of NO2 plus O2. Equation number 1. First one, in that is of reaction mechanism undergo, in that is of 3 steps. First one slow, second one fast, third one that is of fast. In slow, that is of term, first one term which is undergoing in slow motion, in which N25 firstly decomposes to produce, that is N2O3 plus, that is of 1 mole of O2 here. Step number 1 is undergoing, that is performing, that is of slowly to produce 1 mole of N2O3 plus 1 mole of O2. In next one, N2O3, this step undergoing, that is in fast motion to produce NO plus NO2. And third one step here, in step number second, NO is formed, again react with, that is of 1 mole of N25 in fast motion to produce, that is of thrice mole of NO2. Here N2O3 will be cancelled by N2O3 right hand and left hand directions, and here nitric oxide, you know, in left hand direction is now will be cut 1 mole of NO, in that is of right hand direction here. Now add N2O5 twice N2O5, and here that is of thrice NO2, and that is of thrice NO2 plus 1 NO2, 4 NO2, rest that is of right hand direction to have 1 mole of oxygen. So I think we have coded it, that is how we have mentioned this one, equation number 1, this is equation number 1, equation number 1 and equation number 1 by mechanism. The final equation we achieve is, so obviously you know, students of BSc part 1, reaction first undergoing slow motion, second is performing, that is a fast motion, third one undergoing, that is a fast motion here. So you know, here these two terms according to the law of mass action, we will eliminate, we will ignore here, we will concentrate, we will focus slow motion N2O5, and in above reaction rate determining step, that is of first one. In rate determining step we have to count how many number of molecules are present. in that is of slow motion, slow steps. So I think that is N2O5. N2O5 is present here, nitrogen pentoxide is present here. So rate that is of minus d upon dt N2O5 is equals to K1 N2O5 in slow step. It is the rate determining step. N2O5 its number, total number, that is 1. So order of reaction one can identify, one can calculate as that is a 1, while in whole reaction molecularity that is of 2. So it becomes the well known example of pseudo order of reaction, in which order of reaction and molecularity are the different here, 1 and that is of 2, that is of respectively. In chemic timings we will also deliver by the illustration of a specific example to explain the order of reactions, and that is of a pseudo order of reaction, and we will determine their order of reaction and molecularity. Till then, now allow to me join you tomorrow to deliver the next topic. Till then, thank you very much.